As it turns out, the puzzle solutions are completely independent of the file names, the directory names, and the directory nesting structure. All we really care about is the sizes of the directories. So that can potentially simplify our code a lot. So let's see how I simplified it. So I start with two mutable collections. The first one has the input split it into lines and then put into an array deck. We're going to consume that array deck. And the second one is for the sizes that we're going to produce. Both of them are mutable because inside this recursive lambda, we're going to mutate both of them. Okay, so what does this recursive lambda do? So it shall determine the directory size. We have a size so far, which is initially 0. And then we simply check, are there still lines available? And if there are still lines available, we do the usual regex dance here. The difference between this solution and the last is that we here combine the cases for ls and dir, because both of them are now completely irrelevant. We can simply ignore them. Okay, so in the case ls or dir, we simply recur again. Where do we recur to? Well, we have no loop, so we return to the innermost function. So the size so far will stay the same. Right, and then for the file case, we add to our size so far the size of the file. That makes sense. And for the CD case, if we want to go back one directory, then we have added up everything, so we can put that into our sizes array deck and then return that for the recursive callers. Otherwise, we go into a directory, and then if you compare this form and this form, the only difference is here we added the size of a file, and we add the recursive size of a directory, again starting at 0. Okay, and if the lines are empty, then we have to do the same thing that we did for leaving a directory, because at the end of our input, if you will, some cd dot dots are missing. So we simulate some cd dot dots by performing the same operation, basically. Nothing left to do, so put it into our output queue and then return it for our recursive callers. Okay, here the recursive process is bootstrapped. And then curiously, we have to remove the last result because we start at the root and the very first command is cd into the root again. And so the total result will be returned twice, once from this initial recursive call and once from this non-recursive bootstrap call. And so I simply remove the last guy, and that's the only reason why I chose an array deck here instead of an array list. Removing the last element from an array deck is much simpler. Okay, alternatively, we could have simply put this twice in the test. It doesn't mess with the part 1 and part 2 solutions. Okay, and then finally we convert the sizes array deck into a persistent value, so we don't hand out mutable collections. Right, and then part 1 is simplified a bit, so we start out with a vector of numbers. We don't have to map anything, we only have to filter for the ones that we're interested in, at most 100,000, and the rest is just simple addition. And for part 2, also we start with the sizes again. Here are our sizes. Then the used value, so the total amount used in our file system, is the last value that was produced by the recursive process. We can simply peek on a vector gives us the last element in constant time, and the det calculation is exactly the same as before. And then we can transduce exactly the same before, and also here we don't need another map, we already have the numbers. Right, so let me scroll up a bit again in case you want to look at the simplified code.